Okay, so very good afternoon to all. Now this is our MMC lecture. Okay, now we will revise the features. Now you tell me, 8085 is how many bit microprocessor? How many bit micro? Okay, how many byte microprocessor?
One.
How many Nibel microprocessor?
Two.
Very good. Okay, kasahi question येऊ दे, you can answer. Okay. Now next, why it is 8-bit microprocessor? Because of three reasons. Main reason is that ALU is of 8-bit, means arithmetic and logic unit is of 8-bit. Means what? At a time it can receive 8-bit and perform whatever the operation instructed by the user, it will perform on that 8-bit data. Now, if there is a question that if I have given the 100 bits, then what happens? Then out of that 100 bits, it will take first 8 bit, operate on that. Again, after completion of the operation on first 8 bit, it will receive next 8 bit stream. In this manner, it will continue to reach up to 100 bits. Okay. Now, why such kind of scenario is followed in ALW? Because its the capacity is of 8 bit. Now, if I told you that there are the 100 students and we are having one bike having the capacity of only 2, then what we have to do? Again, we have to send first 2 students, again second 2 students, again third 2 students. Okay. So in this manner, we have to complete the entire process. Similarly, as the capacity of ALU is of 8 bit, to operate on 8 bit only, so ALU take 8 bit. Whatever is maybe the data stream at the input side, it may be 100, it may be 200, it may be 1000. Out of that, it only take one single clock period, it will take 8 bit. Okay. In the next clock period, it will take another 8 bit. In the next clock period, it will take another 8 bit. In this manner, it will go on for the computation. Now, next, internal data bus and external data bus is of 8 bit. Data bus is nothing but the connecting wires. So, at a time, that wire can carry 8 bit data. Registers, whatever the registers we have seen up till now, that is the general purpose register. There are 6 general purpose registers, which are these B, C, D, E, H, L. There are the temporal register W and Z. All are 8 bit long. That's why in short we can say 805 is the 8 bit. Okay. Now means in computer branch there is a next control microprocessor for their study, that is 8086. Okay. You are having 8085. They are having 8086. That is a 16-bit microprocessor. Why that is a 16-bit? Again, there is the same reason. ALU of that microprocessor is 16-bit long. Internal external data bus is also 16-bit long. Even internal registers also 16-bit long. Okay, that's why 8086 is a 16-bit. In our case, 8085 is 8-bit. Why? Because ALU is of 8-bit, internal external data bus is of 8-bit, and whatever the registers are there for our use, these are also 8-bit long. Operating frequency is 3 megahertz. Now data bus, again, as data bus is 8-bit long, we need to represent it as a D0 to D7. Address bus, it is a 16-bit long, so we need to represent it as A0 to A15. As we are having 16 address lines, then what means how many locations we can access? It given by the formula 2 raised to number of address lines. Our address lines are 16, so 2 raised to 16. So how we can elaborate that? 2 raised to 6 into 2 raised to 10. 2 raised to 6 is nothing but 64. 2 raised to 10 is 126. Means total memory locations we can access is 64,000 or 64 kilobytes. Now next, as we know that we need to reduce the number of external lines or connecting wires, so we need to multiplex lower order address lines, that is lower order address 8 bits आहेत A0 to A7, that is always multiplexed with the data D0 to D7, because at the same time either address can travel or either data can travel. But to note whether the signal carried on these line, multiplex line, is the data or address, there is a switch called as a latch, and to activate that switch there is a signal called as ALE. Again, power supply required is a 5 volt. Serial communication is also possible via 8085. There is a provision for the serial communication via 2 pins. If we want to send serial data as the input, then we have the pin SID. If we want to send serial data as the output, if we want to take the serial data as the output, then there is a pin SOD. It is having on-chip clock generator. Again, there are the 5 interrupts vectored and means tracked to INTR. Out of these, 4 are vector having specific address inside the system. INTR is not having specific address inside the system because it is not generated by the system. It is generated by the user like us. We are going, those who are performing the operations. Maskable means avoidable. Only trap is a non-maskable means what? It is not avoidable. There are A register, which is very, very important, which is 8-bit long. Result is stored into A. Again, one operand always stored into A. Every time why we are revising this one sentence, that one operand during the arithmetic operation is or logical operation is always present in A. Means what? If I told you that perform the addition of 2 numbers, that is one is the 18 or 20. Out of that 18 or 20, you should copy one number into compulsory into A register. Later on, second number you can copy into any of the general purpose register, that is B, C, D, E, H, L. But one operand is always present in the A register. Okay. Again, after performing the operation, result is also stored into A, and the status of result is replicated into the flag register. Flag register is updated or it is modified by the system when it performs the particular operation. Now, out of 8 flag bits, we are only using 5 flag bits. 3 are don't care flags. Now, next one is PC and SP. Both are the memory pointer. PC tells us which is the next instruction to be executed, and SP is useful when the PC wants to change the sequence of its execution. Okay. Next, 8085 has its a separate control bus to carry the control signals. Okay. There are different ways through which we can give the operand to the system, that is immediate, register, direct, indirect, implied. It is also called as implicit. Okay, in which operand is always mentioned in the accumulator. We need not to give a separate operand or data. Now, this is the basic architecture. Now, basic architecture is divided into 5 to 6 parts. One of the main part is the ALU section, which contains accumulator, temporary register, flag register, and ALU unit. Okay. ALU unit take input from accumulator and temporary register, perform arithmetic and logic operations such as addition, subtraction are the arithmetic operations, and, or, XOR, XNOR, NAND, NOT. These are the logical operations. And after performing the operations, it will store the result back into the accumulator. Temporary register is not accessible for the user. That's why it is also called as invisible register. There are 2 temporary registers, W and Z, and it is 8-bit long. Flag register replicates the status of result. Result is stored into A, and flag register gives the status of result. Okay. Next, here is a second section called as a general purpose registers. There are 6 general purpose registers. Each register is 8-bit long, which is used to store either data, either result, or the memory location. But again, whenever we want to point out the memory location, we need 16-bit data. But the capacity of any register is 8-bit. So when we want to use registers to store the memory location or 16-bit data, we need to use register in pair manner. Okay. Out of that 8, means out of the 16-bit, lower 8-bit is stored by C or E or L, and higher 8-bit is stored by B or D or by H. Okay. So there are 3 register pair we can use: BC, D, and HL. We cannot make pair B with E or pair B with L. B always paired with C. Similarly, D always paired with E, and H always paired with L. If we won't mention the memory location, then HL is taken as by default memory location. Okay. If we particularly mention that store the result into BC, then system store that result into the BC. Okay, when it is 16-bit long. But if we not mention that where to store, then system taken it as a HL. Okay, as a by default register pair to store the data. Next is in green color, stack pointer and program counter. Program counter maintains the sequence of execution. Okay, both are 16-bit long, both carry the or both contains the memory location. PC contains that memory location from which next instruction is to be executed. Stack pointer contains that memory location where the PC goes to branching instructions or PC goes to subroutine, and while returning from the subroutine, it will take the value from the stack pointer and starts the remaining execution. Inserting the value into stack pointer is called as a push operation. Now, taking or retrieving the data from the stack is called as a pop operation. By every push, stack pointer decreases, and by every pop operation, stack pointer increases. Okay. Now, next there is a serial communication session. So this section is used to allow the serial communication of the data. Now SID allows serial input data, SOD allows serial output data. Now see, upper word is the interrupt session. Now 8085 supports 5 interrupts. Out of that, see 1, 2, 3, 4, 5 are the inverse arrow. That is the interrupt signals. Now here INTA. Now this is the new concept to you. Okay. Now up till now about that 5 interrupts you already. Now what you already know about these 5 interrupts, that is trap is the highest priority. Priority goes on decreasing from trap to RST 7.5, 6.5 and 5.5. Again, trap is a non-maskable, remaining 4 are the maskable. These all 4 are the system generated having specific address, and only INTR is a user generated. Now see, then there is a question from your side that what is the use of INTA, ma'am? Okay, INTA is a use camo, madam. See, all these are the input signals, but INTA is the output signal. Means what? It is generated by the system. Okay, so when INTR signal is given by the user, as I have already told you that INTR is the interrupt which is generated by the user. So when user gives the signal on this INTR, and when system receives this signal, then to acknowledge the user that I have received your signal, INTA signal goes high. Means what? Okay, for example, consider करा की तुम्ही कीबोर्ड वर कॅप्स लॉकचं बटन ऑन केलंय. काय होतं सांगा, तिथं जो एलईडी असतो तो ऑन होतो. येस ऑर नो? कधी बघितलंय का? हॅलो. किंवा तुम्ही काय करता, चार्जिंगचं एखादा पिन इन्सर्ट करता आणि तिथं जी रेड लाईट असेल किंवा ग्रीन लाईट असेल ती ऑन होती. हे कधी बघितलंय का तुम्ही? हॅलो.
बघितलंय.
ओके. म्हणजे ठीक आहे. म्हणजे काय केलंय आपण, कीबोर्डवर कॅप्स लॉक ऑन केलं की तिथला लाईट लागतो. ओके. याचा अर्थ काय की आपल्याला कळतं की कॅप्स लॉक ऑन आहे. तसं जेव्हा युजर INTR सिग्नलनी इंटरप्ट देतोय सिस्टीमला, तेव्हा युजरला कसं कळणार की तो इंटरप्ट सिस्टीमला मिळाला आहे का नाही? मग काय होतं, INTR सिग्नल सिस्टीम कडून INTR सिग्नल हाय होतो. मग जर तिथं आपण एखादा एलईडी लावला तर काय होतं, तो ग्लो होतो. म्हणजे आपल्याला काय कळतं की आपण दिलेलं इनपुट सिस्टीमला मिळाले. फॉर एक्झाम्पल, मी कीबोर्डवर कॅप्स लॉक दाबलं. ओके, तिथला एलईडी माझा ऑन झाला. कॅप्स लॉक दाबलं म्हणजे काय, मी INTR सिग्नल दिला आणि एलईडी ऑन झाला म्हणजे काय, मला सिस्टीम कडून कळालं की आता तुमचं कॅप्स लॉक ऑन आहे. तसं INTR सिग्नल जेव्हा सिस्टीम रिसीव्ह करते आपली, तेव्हा ऍज अ ते युजरला एक्नॉलेजमेंट द्यायला, INT म्हणजे काय, INTA इंटरप्ट, ए म्हणजे काय, एक्नॉलेज. एक्नॉलेज म्हणजे काय की बॅक टू तुम्हाला कळणार. आता फॉर एक्झाम्पल व्हॉट्सअपवर आपण मेसेज सेंड करतो. ओके, समोरच्यानी जेव्हा तो मेसेज रीड करतो तेव्हा ते ब्ल्यू होतात लाईन्स. कधी बघितलंय का? हॅलो. हॅलो.
हा मॅडम. येस.
ओके, सगळ्यांनी बघितलं असेल. जेव्हा आपण व्हॉट्सअप यूज करतो, आपण म्हणजे सेटिंग पण असतात ते ब्ल्यू होऊ नये म्हणून, पण आपण एक जनरल म्हणजे कंडिशन चेक करू की जेव्हा आपण मेसेज सेंड करतो तेव्हा काय होतं की समोरच्याला तो मेसेज मिळतो आणि जेव्हा तो रीड करतो तेव्हा त्या लाईन ब्ल्यू होतात. त्या ब्ल्यू लाईनमुळे आपल्याला काय कळतं सांगा बरं, की ज्याला मी मेसेज सेंड केला त्यांनी तो रीड केला. समजते? म्हणजे त्याला काय म्हणायचं, एक्नॉलेजमेंट. एक्नॉलेजमेंट म्हणजे काय की जो काही सेंडर आहे त्याला कळणार की रिसिव्हर कडे रिसीव्ह मेसेज झालेला आहे. सेम वे व्हेन युजर जनरेट और गिव्स द इनपुट टू INTR, आफ्टर रिसिव्हिंग दॅट सिग्नल INTR, नाव system generates its acknowledgement and gives high signal to INTA. समजतंय का? yes or no सांगा. हॅलो,
हा येस
येस मॅडम.
सगळ्यांना कळतंय का? नेहा, वैष्णवी, पूजा, श्रद्धा, शिवाजी, अरबाज, हे समजलं का आपण काय बघतोय ते? हॅलो, हॅलो, हो का नाही? काहीतरी रिप्लाय द्या.
समजले मॅडम.
यस, ओके ओके. नेहा, विशाल से यस, ओके ओके, ठीक है. So see, interrupt control is a separate section to handle the interrupts coming to the 8085. Okay, there are 5 interrupts which is supported by the 8085. Now whatever the interrupts you can say about the interrupts, that is maskable, vectored and non-vectored. Now here INTR is the user generated interrupt. When system receives the INTR interrupt, it will generate its acknowledgement and makes the INTA signal high. That's why INTR is the input while INTA is a output pin. Why it is output pin? Because it is generated by the system. That's why it is output pin. Now next, address buffer and address data buffer. Address buffer is a unidirectional while address data buffer is a bidirectional. When we need to transfer the address, we only need outward arrow from the system. But when we want to receive or send the data, read and write operation, we arrow. What is the use of these directional buffers? These buffers are used to maintain the signal flow. Okay. Now, next, this instruction register. Okay, this ping session. Instruction register is the intermediate part between bus and the decoder. It will take the opcode part from the bus and transfer that opcode part towards the instruction decoder. Again, more in technical language, आपण काय सांगू शकतो? Instruction register hold the opcode and transfer that opcode to the instruction decoder. Now, about instruction decoder. Now, it will receive the opcode from instruction register and decode the instruction. Okay. According to the and accordingly, once it decode the instruction, accordingly it will generate timing and control signals, and that signals is transferred towards the timing and control unit. Okay. Now, once the timing and control signals are generated, it is transferred to all the remaining part of the system for appropriate action. So this all about your architecture. See, in this section you can write, means there is a separate question. Okay, for timing and control unit there is a 4-mark separate question, that is explain the timing and control unit of the 8085. In such a type of question you have to write the function of each and every pin of these lines. But in the architecture, no need to explain it very deeply. Okay, just you have to mention its function or working. Why? Because it is too much lengthy. Now, once you are able to writing the sentence, you come to know that it is very, very lengthy. To draw the architecture, it will take near about 5 to 6 minutes. Okay, and after that you have to explain. Sometimes in the equation only they can mention that explain the following 4 blocks of the architecture. Otherwise, they means it is up to you that they will ask the question like draw the architecture and explain any 4 section or explain any 2 section out of the architecture. So in that case, you have the liberty to choose any session. But if they have particularly mentioned the particular session, then you have to go for that. Okay, but you need not to explain each and everything about the interrupts. You only means draw that table. It is also sufficient. If you want to elaborate, then you can write 2 to 3 sentences about each interrupt. Okay. Now this is all about the architecture. Now is anything remaining in this? Increment and decrement latch. So see, increment and decrement latch is when any particular memory location is operated, then increment and decrement latch automatically incremented it by 1 or decremented it by 1. So because of these latch, PC automatically incremented by 1 and decremented by 1. Okay. So today's new part, that is pin diagram. Okay, which already I think so you have drawn it yesterday. Okay, maximum जणांनी मला homework पाठवला, बाकीच्यांनी का नाही पाठवला? ज्यांनी होमवर्क नाही पाठवला त्यांनी आज डबल काढून पाठवायचं आहे आणि ज्यांनी काल पाठवलं त्यांनी एकदा सी डायग्राम काढायची आहे. नाव सी व्हॉट इज अबाउट द दिस इज अबाउट द पिन डायग्राम ऑफ 8085. जर तुम्ही पिन 8085 आता जर म्हणजे कसं असतं बघायचं म्हणलं तर ही डायग्राम बघा. ओके, कसं असतो इथं काय असतं तर तुम्हाला इथे 10, इथं अगेन 10 10 10 you are able to see 40 pins, okay, in this session. Okay, now these 40 pins are described as follows. Now pin number 1, now again there is a question in the exam, that is draw the pin diagram of 8085 and explain the following pins, or explain any 10 pins, explain any 2 pins. Okay, or sometimes they have mentioned the particular pin number, that is draw the diagram of pin diagram of 8085 and explain the working of pin number 32, 33, again 30 or 11. Okay, so such type of question is going to be asked in the exam. Now see, if we want to minimize the pin diagram, then we can see this diagram according to the session. Okay, now different sections are there. See, this is the SID or SOD, that is the serial input output port section. This is the interrupt section. This is the only input signal section. Okay, this is the output section. This is a control signaling. Here is the address bus, multiplex address and data bus, and here is a data bus. Now see one by one pin. Here is pin number 1 is X1, X2, reset out, SOD, SID, trap, RST 7.5, RST 6.5, RST 5.5, INTR, INTA bar. Now yesterday we have seen the concept of bar. Now there is a question to all of you. INTA bar is active low or active high signal?
Active low.
Active low signal. What is mean by active low signal? It is activate when? Active low means what? It is activated when low signal is applied to it. Means what? If we want to activate INTA bar, means what? If we have given 0, then it will activate. If we have given 1, then it will not activate. Here inactive. Okay. Next, AD0 means 0th line of the data or address. AD1, AD2, AD3, AD4, AD5, 6, 7. These are the lower order address which is multiplexed with data. That's why they are in the combined manner. AD means what? Address and data are in multiplex manner. And VSS is nothing but your ground. VCC is nothing but your +5. Okay, so these are your power pins, 20 and 40. Now see here, A8, A9, 10, 11, 12, 13, 14, 15. So A8 to 15 are your higher order address bus. See, this is your higher order address bus, and this is your lower order address which is multiplexed with data. As we have already seen in the architecture, see, higher order address bus is a unidirectional, फक्त outward जाणारी arrow आहे, आणि lower जी आहे ती bidirectional. Similarly, to show, we have to show it into the diagram. Higher order address bus is only having outgoing arrow. Why? Because address is always transferred by the system to the memory location. Now here we are transferring data also. Data may be input when we are doing the reading operation. Data may be output when we are doing writing operation. So for lower order address and data bus, we have to show bidirectional arrow. So we have to take care of this. Okay. Now see. Next one is a ALE, that is address latch enable. Next one is a write bar. Again, tell me it is active low or active high signal. Hello. Hello.
Active low.
Active low. Why? Because there is a bar. Again, read bar. Whenever there is a line on the arrowhead, we have to read it as a bar. So write bar, read bar. Okay. Now S1, here is a S0 and here is a S1, which is used to control the read and write operation. Now see, here is a 34 number pin. IO/M चा bar. IO/M bar. means IO is a active high or active low? Active high. Why? Because hello, because on the arrowhead means on the head of the IO there is a no bar. So IO is active high. M is active low. Why? Because on the M's head there is a bar. So IO is active high signal. M is a active low signal. How we can read it as a IO/M bar. Okay. Now what is means there is a question, what is the use of IO/M bar, or what is mean by IO, or what is mean by M? So this IO stands for input output device. Okay. And M stands for memory device. Now to understand this concept, consider one scenario, that is, I told you that make one PPT on your computer and save to D drive of your computer. Okay, make one PPT on computer and save it to D drive. Okay, now again I have asked you the same but very differently, that save this PPT on my pen drive. So there is a two scenario, that means you have to save your files on your D drive of your computer, or second case is you have to save your file on your pen drive. So if you are going to save it on your memory, or when your D drive, E drive, which is on the computer, then you are accessing your memory. And when you are saving, means copying that PPT into the pen drive is what? It is a IO device, input output device. You can take a data from pen drive, or you can save the data into the pen drive. So it is called as a IO devices. Okay. So if we want to perform read and write operations, then we need to explain the system, or we need to give the signal to the microprocessor that whether we are going to access IO devices or whether we are going to access memory devices. Okay. If we are going to, maximum cases we are accessing the memories. Okay. In very few cases we are interested in IO devices. Why? Because it is very easy for us to access with the memory, inbuilt memory. Okay. So मी जर तुम्हाला सांगितलं की असा एक कम्प्युटर मी तुम्हाला गिफ्ट देते की ज्याच्यामध्ये मेमरीज नाहीये, ओके, चालेल का? नाही चालणार का? कारण की त्या प्रत्येक केस मध्ये वॉट एव्हर यू आर मीन्स वर्किंग यू आर डुईंग ऑन द पीसी, you have to explain, means you have to save that to the memory, so that in the next case when you are referring that one, you can get it easily. So IO mentions when your operation is related to IO devices, and M bar is activated when your operation is related to memory. Okay. Now next, ready. As yesterday's lecture we have seen introduction about the ready. This pin is used when we are doing the peripheral operations. When our PC is doing operations with the peripherals. Okay. So means what? Peripheral devices means whatever the means the devices we are connected externally to the system. Now see, in our CPU, what we can connect externally? We can connect monitor, we can connect keyboard, we can connect mouse, we can connect again scanner, printer. Okay. Then what we can connect again? We can connect our modem, or we can connect. Means there are different devices we can able to connect with that. Fax machine. Okay. So these are the peripheral devices. Now, when we are connecting these peripheral devices, due to the high speed of the system, they cannot able to match with the system. So they generate the, means they activate the ready signal. So to match the speed with the peripheral, PC has to wait for some time. Okay. It will introduce the delay cycle in between their operation. And when it receives the ready signal, it will again try to transfer the data. Means what? PC सुरुवातीला त्यांना डेटा देतो, पण आता PC कडून एकदम सगळे बिट्स आलेले आहेत. ओके, ते रिसीव्ह करू शकत नाहीयेत. मग पुढचे बिट्स पाठवायच्या आधी तो काय करतो? PC वेट करतो. आणि मग नंतर कधी स्टार्ट करेल? जेव्हा तो रेडी सिग्नल त्याला ऍक्टिव्हेट झालेला दिसतो, तेव्हा मग तो राहिलेले स्टार्ट करतो. म्हणजे मी तुम्हाला 10 सेंटेन्स एकदम सांगितलेत आणि म्हणते आता लिहून घ्या. ओके, मी म्हणलं आता मी जे सांगते ते लिहून घ्या, आणि असं म्हणून मी फास्ट 10 सेंटेन्स तुम्हाला सांगितले. ओके, मग काय होऊ शकतं? एक तर तुम्ही त्या 10तले 5-6 लक्षात ठेवू शकता, किंवा तुम्हाला ते 10 सेंटेन्स द्यायला वेळ हवा असतो. ओके, मग तुम्ही काय म्हणता? मॅडम थांबा. मग त्यावेळेस काय करणार? मी थांबणार म्हणजे काय केलं? मी डिले इन सायकल इंट्रोड्यूस केल्या, म्हणजे मी थांबले तिथं. ओके ना. नेक्स्ट जेव्हा आता तुमचं ते 10 लिहून होईल, तेव्हा तुम्ही काय म्हणणार? हा मॅडम आता पुढचं सांगा. मग तुम्ही हे जे सांगताय की आता पुढचं सांगा, हे तुमच्याकडून जेव्हा येत आहे किंवा तुमच्याकडून जे येत आहे त्याला काय म्हणायचं, रेडी सिग्नल. सो रेडी सिग्नल इज used when the system wants to communicate with the peripherals. When the ready signal is high, then only microprocessor should start communicating with peripherals. Okay. Next one is a reset in. Again, it is active low signal. Reset in bar. Now, in technical word, reset means off or turn off or switch off. Okay. So when you want to turn off the PC, then you have to activate this signal. How you can activate this signal? By giving low voltage. Why? Because it is a active low signal. So when you are going to apply low signal to reset in, then your system gets turned off. Okay. Now next is a clock out. Clock out means what? As you know that there is a inbuilt clock generator in 8085 which generates the operating frequency of 3 megahertz. If you want to give this clock to the other peripheral devices, then this pin is going to be used. Next one is a HLD and HOLD, hold and HLD. I think yesterday's lecture we have not seen this. Hold and HLD. Okay. Okay. See, now we will see here. Hold and HLDA. See, hold is the input signal while HLDA is the acknowledgement. Now see here. Where is the HLDA? See here. Hold is a 39. Okay, it is a input pin and HLDA is a output. Means what? It is the acknowledgement. HLD means hold, A means acknowledgement. Now see, what is the use of these two pins? See, now when system communicates with other systems and other system wants to use the internal buses of 8085. Okay. नाव त्याच्या आधी ही सिस्टीम ही कन्सेप्ट समजून घ्यायच्या आधी मी तुम्हाला एक कंडिशन सांगणार आहे, त्याच्यात मला तुमचं ओपिनियन सांगा. ओके. नाव तुमच्या एका मित्राने किंवा मैत्रिणी तुमच्याकडे गाडी मागितली, पण तुम्हाला आता अर्जंट काम आहे जे की 5 ते 10 मिनिटात होते आणि तिने तुम्हाला म्हणलंय की मला तुझी गाडी दे. तुम्ही त्याला काय म्हणताल किंवा तिला काय म्हणताल? नाही दे,
गाडी दे म्हणणार.
हॅलो. सी, ते कट करा, परत एकदा बघा. हा, रिपीट करते. ओके. हे बघा, तुमचे अतिशय बेस्ट फ्रेंड आहे किंवा ओके, आणि तिने तुम्हाला किंवा त्यांनी तुम्हाला गाडी मागितली. त्याचं पण अर्जंट काम आहे आणि तुमचं पण अर्जंट काम आहे. तुम्ही नाही म्हणू शकत नाहीये, त्याला तुम्हाला द्यायचीच आहे. आणि त्याला असं नाही की म्हणजे त्यांनी फक्त मागितले की मला आज तुझी गाडी लागणार आहे, पण आता 5 मिनिटासाठी तुम्हाला अर्जंट काम आहे, तर तुम्ही काय करता?
घेऊन जा.
5 मिनिटांनी घेऊन जा.
5 मिनिटांनी घेऊन.
ओके, बरोबर. सगळे हुशारच बाबा टीवायचे. ओके
मॅडम.
दुसरी नाही, एकच गाडी आहे. हॅलो. ओके. सेम वे इथं सिस्टीमचं पण तसं होतं. काय होतं, जे काही पेरिफेरल दुसरे एखादे मायक्रो प्रोसेसर जे असतात, नाउ डेज तुम्ही जर बघितलं असाल तर आता फॉर एक्झाम्पल तुम्ही कम्प्युटर घ्यायला जाता तर तिथे तुम्हाला ग्राफिक्स कार्ड विचारतात. ग्राफिक्स कार्ड म्हणजे काय असतं की तो एक छोटा प्रोसेसर असतो की तो ग्राफिकल जे काय असतात म्हणजे आपल्या ज्या डिझाईन्स असतील, ऑटोकॅड असतील किंवा जे फोटोशॉपचे वगैरे सॉफ्टवेअर असतात ते फास्टली रन केले जातात का, कारण की तो त्याच्यासाठीच तो प्रोसेसर डिझाईन केलेला असतो. ओके. सो आता आपल्या सिस्टीमचं आणि आता या सांगितलेल्या एक्झाम्पलचं काय कनेक्शन आहे ते सांगते. सी, आपला जो काही प्रोसेसर आहे हा मेन प्रोसेसर आहे की ज्याच्याकडे स्वतःच्या इंटरनल बसेस आहेत. फॉर कंट्रोल सिग्नलिंग कंट्रोल बसेस आहेत, डेटा ट्रान्सफर करायसाठी डेटा बस आहे, ऍड्रेस ट्रान्सफर करायसाठी 16 ऍड्रेस बस आहेत. ओके. तो जर एखादे पेरिफेरल प्रोसेसर जो आपण कनेक्ट केलेला आहे तो जर याला त्याच्या बसेस रिक्वेस्ट करत असेल, ओके, नाव कधी कधी काय होतं की मायक्रोप्रोसेसरला स्वतःचे इंटरनल पण कामं भरपूर असतात. मग प्रत्येक वेळेस पेरिफेरल्सशी कम्युनिकेट करायचं आपण होऊ शकत नाही. आता तिथे एक सेपरेट सब्जेक्ट एक येतो कम्प्युटर ऑर्गनायझेशन. याच्यामध्ये या कन्सेप्ट जास्त डिटेलमध्ये आहेत. इव्हन तो कम्प्युटर ऑर्गनायझेशन आता सध्या तुम्ही त्याचा विचार करू नका, फक्त कन्सेप्ट काय ते बघा. तो जेव्हा एखादा पेरिफेरल मायक्रोप्रोसेसर आपल्या मायक्रोप्रोसेसरला त्याच्या बसेस मागतो, ओके, तेव्हा मायक्रोप्रोसेसर सुद्धा काय करतो की म्हणजे पेरिफेरल प्रोसेसर बसेस मागतो म्हणजे काय की तो त्याला होल्ड सिग्नल जनरेट करतो. ओके ना, म्हणजे काय की मला तुझ्या बसेस दे. पण मायक्रोप्रोसेसर काय करतं, त्याचं तर ऑनगोईंग काम चालू आहे. तो मायक्रोप्रोसेसर काय करतो, त्याचं ऑनगोईंग काम जे आहे ते आधी कम्प्लीट करतो आणि मग त्याला अवेलेबल करून देतो फॉर टाइम बिईंग. त्या टाइम बिईंगसाठी तो प्रोसेसरला त्याच्या स्वतःच्या बसेस देतो. कोणत्या बसेस देतो, तर नॉर्मली ज्या काही बसेस असतात त्या ऍड्रेस अँड डेटा बसेस असतात. सहसा कंट्रोल बसेस दिल्या जात नाहीत कारण की त्या इंटरनली कंट्रोल करतात सिस्टीमचं ऑपरेशन. सो whenever my peripheral microprocessor or whenever peripheral devices request microprocessor to access its buses, then by generating the signal. टाइम अप झाला का? तुम्हाला काही आहे का 12:30 नवीन लेक्चर 1:30 ला? बरं ठीक आहे. ठीक आहे, स्क्रीनशॉट घ्या प्रेझेंटीचा.
हा मॅडम आहे.
ओके ओके ठीक आहे. स्क्रीनशॉट घ्या प्रेझेंटीचा आणि उद्याच्या लेक्चरला आपण ही कन्सेप्ट
घेतले.
डिटेल मध्ये बघू. ओके ठीक आहे चालेल.